Hi, welcome to the Inventory Framework plugin showcase. Today I'll be giving you a tour of the plugin and showcasing its capabilities and features. To begin, let's open up the inventory and see what we're working with. To begin, we have a spatial grid where items can have dimensions. They can also have custom shapes, so we can even put items in the middle here. Things can be moved around and they have to respect the spacing between each other. In traditional 1x1, everything is always transformed into a 1x1 item. So we can put things here, we can equip items, we can even inspect, we can even open. Then the last container type, we have data only, which are infinite because they have no concept of spacing. They are essentially just data. Usually these types of containers are hidden because they contain things like wallets, currency, things like that you don't want to be bothering with spacing around or having the potential problem of running out of space inside of a container. IFP has also been designed in such a way that not all inventories are supposed to look the same for every asset. So if we take a look at the RPG example, we can see the inventory grid has been customized, the tiles have been customized, the item icon has been customized, some even have a strip to show their rarity, and so forth. When you start, you might want to go over the documentation, and the example project also has its own documentation. Keep in mind that the example project is dissected into several plugins. There's the IFP_common assets, and each example project is essentially its own plugin as well. We can take a look here at the plugins folder. You have common assets, you have RPG. To begin, let's start going down the hallway. The basic foundation of IFP includes a data asset for your items, an inventory component to handle the inventory, of course, widgets to handle, obviously, the visuals for the player, then two primary structs that are, of course, the container holding all the data, and the item struct to hold all the data for the item. First feature we'll be covering is traits and components. The traits are data-only customizable instance objects which can be retrieved during runtime and are customizable per asset. Components are spawnable actor components that attach to the owner of the inventory component whose logic and data can be tied to the trait and item structs they were associated with. At the bottom, you'll find the link to the documentation. If we open it up here, we get a lengthy documentation about what item traits are and what item components are and how they work. To see what it looks like in the editor, I've opened up one of the editor utility widgets, which we'll be covering in a moment. We can go into its traits and components. We find the consumable. We have the animation to play. We have a variable that we can fetch through here, get health to restore, and adding this is extremely simple. You just add a variable here, give it a category, and it will appear. We can even remove this, and now it's even gone. Item and container fragments is a brand new feature in 3.0. Fragments are pure data structs which can be added, removed, and modified during runtime. This allows you to add any custom data to containers and items without modifying the base plugin. Fragments benefit from IFP's optimized networking system by only replicating the data to clients the inventory component finds relevant. For more information about networking, you can go into Introduction and go into How does the networking work. For fragments, you can find it under Systems, Fragments, which also covers lengthy documentation about how to use it and how it works. For an example of what it actually is, we can take a look here. This item can receive fragments which are tags. You can override its settings. You can add a random item count. And you can even give it default items. We can see here that this backpack has a gun in it. This gun has a sight in it. And designing something like this in a non-recursive struct is really annoying. With recursive structs, this process becomes a lot simpler. We can go here into the back. We can go into the backpack, and we can see here's the default items fragment. We open it up, and it is adding this gun into the weapon container, which is declared in the data asset. If we take a look at its default containers, we have here the weapon container, and this gun also has the same fragment. So it has so it's adding this site to its site container. If we take a look at this one, we can also see in its default containers, it has a site container. The most powerful fragment is the tags and tag values. All items and containers have a tag and tag value system, allowing you to add durability systems, rarity, and other similar systems easily. Tags can be added and removed during runtime, and tag values can be modified, added, and removed during runtime as well. This also means you can override tags on items inside the level editor. The tooltip can even replace any text containing the tag with the value. So if we take a look here at the gun, we can see here current durability is 17. If we take a look at the gun, we can see here the description. This text might be a little bit small. We can see here it is replacing this tag value with its actual value. And the same goes with the helmet and so forth. Tags also have their own documentation. It includes a tag value calculation class, which acts similar to the calculation class in GAS. IFP includes several ways of containing your gameplay logic around items. The item instance is a simple object that is tied to the item struct and can be held responsible with certain gameplay logic. This instance can be the host of all gameplay logic that many other inventory systems would place in the item actor, without the heavy cost of spawning an actor. These can be created in two ways. Declared in the item struct, they are instance editable, so you can modify variables for that specific item instance very easily. Inside the item asset, this method is a global method, so all items in your project with this item asset will automatically get an instance created. These can be optimized by enabling construct on request, which means the instance won't be created until you try to retrieve it. Documentation again can be found all the way down here, and there is even a much broad topic about where to store your runtime logic, including gas abilities, traits and components, the item actor, and it also covers the issues with trying to contain your logic inside of an item actor. So the item instance system allows you to reap all the networking benefits and serialization benefits of structs without the hassle of UObjects. IFP includes an ability system integration system. An important note around IFP's design is that it was not built with any specific ability system in mind, but rather have good extension points to allow for it to interact with any ability system for any ability system to interact with IFP. This design philosophy has led to IFP being extremely easy to integrate with any ability system. IFP does provide item abilities, which are meant to look and behave as similar as possible to gas abilities. But instead of treating the character as the owner, it treats the item as the owner, allowing multiple copies of the same ability, but each is managed by the item that they belong to. Some people might know that gas only really allows you to do instance per actor, but when you're dealing with inventory systems, you might not want that. IFP also provides a basic gas integration module to quickly get you started with a basic gas implementation. If we take a look at the documentation, there's even a video tour. And remember, it is not enforcing gas onto your project. It simply has a native gas module, and there's even documentation on how to remove it if you do not plan on using gas. Like I discussed earlier, the equipment system is recursive, so we can have a backpack with a gun with a sight on it on the player, in item actors, and so forth. We even have some quick loot examples, so we can just grab the sight here. We can also just loot the entire backpack. This also has extensive documentation, and you can even completely replace the equipment system in IFP, and it is extremely straightforward. The example project in IFP contains a equipment helper component, which handles IFP's default equipment system. And if we take a look at how it even works fundamentally, it is just binding to these two events. So that is how simple it is to replace and put in your own system. Of course, an inventory system wouldn't be complete without some chests or some interactables. You can, of course, open it up. You can drag things out. You can put things in. And all of the interactions are automatically replicated. We can even customize this container inside of an editor utility, which is called the inventory helper. If we take a look at the inventory helper, we can see we can click and drag things around, and it will automatically handle all that data for you. You can even add things just by clicking an item in the database. You can, of course, move things around. You can add things. You can even right-click and modify the item like so. Do note that IFP comes with a bare bones interaction system, which again, it contains documentation on how to replace it. IFP also includes a highly adaptable loot table system. Loot tables are recursive and can be dictated in the item asset and individual actors either through the class defaults or per actor throughout your level. Loot tables are the primary way of expanding your game via modular game features to help with future DLC releases. If we take a look at the documentation, you have a loot table component, which is a host of loot pool objects, and you can customize these loot pool objects to work however you wish. IFP includes two examples. One is just a simple loot pool, and the other one is a tag loot pool to function with modular game features. We also have vendors. We have 3 different types of vendors. Do note that vendors are extremely abstract. So these aren't vendors that are hard-coded into IFP. These are just blueprints that I've designed to make my vendors behave the way that I want. We can, of course, talk to the vendors. We can try to buy. We don't have enough money for this. We can sell to vendors. This one has 15. We can sell him some. This one has a visible wallet, so we can see all of his money. We can, of course, sell him the apples. We get some money back. A optional but powerful crafting system comes with the plugin as well, which can be removed very easily. All classes can be found in the content browser context menu, inventory framework, crafting. Some recipes have a display requirement, which will only show when you're near this table. So we take a look here. We can only craft the helmet, but if we stand near this, we can now craft the mystery item. We can also press here, craft the item. We have now destroyed the crafting item to get a helmet. Of course, it comes with documentation. It is also fairly simple to create virtually any class inside of IFP. Override settings are another example of the fragment system. The override settings just allow you to create unique items in the level without creating a new data asset, or potentially even allowing your players to customize their own items. For example, changing the name. If we take a look here, this is the cool helmet, this is just a regular helmet. And we loot it, we can see it even keeps its name. Not just containers and items can have tags, it's also individual tiles. Containers have the ability to assign tags to individual tiles, unlocking unique gameplay logic or customization. This just uses the IFP tiles hidden tag to hide specific tiles. So we can see here, it's a little bit hard to see because it's black on black, but the corner tiles are hidden, creating a unique shape that the item can't be dropped into. Some people have expanded this to create, for example, power-up slots. So if a gun was in this slot, it would receive some kind of power-up. This again has its own documentation. Many products out there forget to implement good developer tools. IFP has not forgotten about this. It includes 2 very powerful developer tools. The inventory helper allows you to design. The inventory helper tool allows designers to more easily modify containers and provides them with a near one-to-one view of a container or item while inside the editor. The item editor is a powerful tool that helps you create custom tools for your items, such as an icon editor without touching slate. We can see there in the bottom toolbox, you have an icon editor, a shape editor, and a sockets editor. And those are all designed using UMG. IFP provides a powerful preview system that allows you to not just inspect items, but also generate item icons. This is not just limited to items, this also works on all actors, like the player character. There is no special actor component hierarchy setup required. The only requirement is an actor reference. The item editor tool allows you to preview your settings in editor or save the icon to a texture to optimize performance. For example, this is using the preview actor. This is also using the same preview actor, and there was no actor hierarchy requirement or class component requirement. It automatically just duplicates the appearance of your actors. This again comes with its own documentation. It includes camera management, optimizations, leader poses, and helps with debugging certain issues. External objects is a simple array for both the item struct and container struct. There are helper functions for both adding and removing objects from this array. What this array allows you to do is have other objects, such as widgets, receive the same update events from the external objects interface that the item widgets and container widgets receive without using delegates, which listen to all items, whereas these events are specific items and containers. This can be used for hotbars, ammo counters, quest trackers, and more, where a specific item needs to be monitored. The example project uses the tooltip as an external object. So if I were to be hovering over this and the durability changed, the tooltip would change instantly with it, without using delegates. This of course comes with its own documentation, and adding custom events is extremely simple. There's just one function, get objects for item or container broadcast, and then you can just call your interface. This system has greatly simplified the communication between IFP and your own project. IFP also includes a multi-threaded item query. The item query system is a great way of improving performance in large and complicated inventories by utilizing multi-threading and storing references to items that pass their filter for later retrieval. The main area that C++ dominates blueprints in regards to performance are heavy for loops. These queries allow blueprint programmers to create highly efficient queries without touching C++. And of course, includes its own documentation, and even some performance numbers to understand how much faster this is over regular hard-coded item queries, especially those written in blueprints. IFP also includes Gamepad Navigation. IFP does not rely on plugins like Common UI to automatically handle Gamepad Navigation due to a few shortcomings of Common UI, and so IFP does not enforce people who do not want to use Common UI to use it. Thanks to this, Gamepad Navigation can be highly edited. For example, not navigating tile to tile, but rather item to item. But that does not mean Common UI can't be integrated. Remember, Common UI just reworks how navigation is handled and gives you a collection of widgets to handle common widget cases. This of course includes its own documentation, including Common UI integration. If we take a look at the inventory, I can move my cursor around with the cursor, I can pick things up, I can rotate, I can do everything that I could with my mouse with just the keyboard and gamepads. Last but not least, we have item sockets. Item sockets is a system that allows you to assign a socket to an item, similar to a static or skeletal mesh. This socket contains a name, a local position, a tag, a rotation, then using helper functions to get the tile index of that socket, with another function allowing you to provide an offset to the socket's tile. The item socket system can be enabled for items by opening the item asset and adding the socket manager trait. It is recommended to open the item editor tool, as that will provide you with an editor utility widget to visually assign your sockets. So like this, we can see the rotation of the currently selected socket in the top middle. This of course includes its own documentation. It is fairly short since it is mostly just two functions. Some people have used this to include power-ups for nearby items. So for example, a torch and having a sword above it would grant the sword some kind of fire buff. That has been it. Thanks for watching. Hope to see you in the next one.